My name is Chuck Tatham. I'm here with Andy Walton.
How's it going?
Andy, to take you through a quick presentation, will be 30 minutes. We are covering a popular topic these days around what we call cloud burn, but let's just call it generically cost that you don't want to have related to cloud infrastructure. In our experience, there is in every environment opportunity to save, and for a lot of enterprises today, that's top of mind. We are going to take you through Densify, but with a focus on something called Intel Cloud Optimizer, which is powered by Densify. It's branded by Intel, offered by Intel globally, and a program around this topic that qualifying enterprises can take advantage of. We do want to start with a poll, though, just first of all, to keep people engaged. All of what we're going to talk about today is the importance of actually looking at your consumption and whether you have waste or price for performance opportunities by making better infrastructure decisions. So that's our question, and we will put up the results. It's actually not a surprise, actually a bit of a surprise, because 0%, Daniela, if we can post the results, 0% say they're just relying on getting the best price. Over the last couple of years, we've seen a pretty big focus on things like savings plans and reserved instances as the way companies are going to get their savings. In a lot of cases, because, well, I'll talk about it, finance doesn't control infrastructure. So that's the one tool they have. But 71% saying, yes, we're looking at actual efficiency, which is exciting, because that is what our engine does. We don't focus on the bill or the dollars you're spending in the cloud. We focus on optimizing the resource that you are giving your workloads. So Densify is an engine that gives precise recommendations to optimize for performance and cost. And we do that on the 3 major public clouds, and as well, container infrastructure, Kubernetes-based or OpenShift managed. Densify Analytics for optimizing resource, which ultimately will help you with your bill. But a balanced approach is helping you with performance, price for performance, and cost, which is a great area of interest for Intel. So what is ICO? Well, ICO is powered by Densify. It was selected by Intel to power this offering. It is an instance of Densify for qualifying enterprises that is funded for a full 12 months. Intel covers the cost. It includes assistance from Intel experts and Densify staff as usual. And it includes advanced analytics that we are working on with the help of Intel to match workloads to often, not only size, this is the right size stuff, but often missed CPU and cloud instance features, and there are hundreds, that can significantly improve performance. So yes, we're talking about cost, but we are talking about performance. In a lot of cases, better performance, better throughput will improve your price because you're getting more work done with the same infrastructure. And we'll talk more about that. So when we look at cost, yes, you have to make sure you're getting the right discounts. Who wants to pay more? And if you're making commitments to those massive providers, you want to make sure you're getting the right discount. But the majority of the opportunity in most cases now is controlling the optimal type and quantity of resource that you're consuming, because it's a very simple equation. The price you pay times the quantity you use drives your overall cost. Now, in most organizations, this looks a little bit like this, where you have application owners, lines of business, cloud engineers who are working with their development tool chains to put new workloads or manage existing workloads in the capacity you choose to use. That results in a bill that lands in some finance organization who, in most cases, are consistently surprised by the cost, and they do what they can to reduce cost. The problem is that there is a massive chasm between this problem and the people that control infrastructure. They see the bills in many cases, but they really care little about the cost, or not enough about the cost. They care mainly about performance, which is their primary day job. So something is needed to bridge this gap, and that's really where we are working with Intel to approach this problem. The finance world has a wealth of things they can use to understand, distribute, and decide how much they want to commit to. There are lots of things that help them manage the asset. There are well understood tool chains that deliver workload and build workloads and applications. But the world of instance optimization and addressing this gap has seen really minimal effort historically. And this is where we come into play. Instead of humans doing best efforts to come up with the right answer on a workload by workload basis, we do it programmatically and analytically with ICO. So how does it work? Well, it watches to a great degree of detail the behavior of the workloads over time and builds predictive models. So it's not looking at just averages and peaks and valleys. It is understanding and building a predicted operational pattern that also understands the relative power of the infrastructure, the benchmark of the infrastructure you're sitting on. And it does this across CPU, memory, IO, and other things to construct a very accurate model of the requirements of that workload. We then constantly compare it to the full catalog. This is an AWS example, and only a piece, the C offerings or instances from AWS we're simulating here. But combined with policy and the ability to say what your organization is interested in from an aggressiveness or conservatism perspective, as well as an understanding of the features or technical things that are required, deep policy, as well as the features, the technical attributes, to determine what is the best instance for your workload to safely go into while factoring in all of these other sensitivities. And we give you that very precise recommendation. So it's not a suggestion. It's not a you might do better here. It is you will do better if you move to this instance type. It will also tell you if something is no longer suitable because of some particular thing under the covers that may mean that your stuff will actually not even run there. So very, very precise. And it's the precision that's required to get over what is holding most savings initiatives back these days, and that is getting engineers to actually take action. Because if you give them something flawed or a suggestion or something basic with little proof, they won't listen to you because the details are critical. If you're sitting in an M3 instance and you're wondering whether you could do better within the family, there is a huge amount of complexity, and I'm not going through all these line by line, but you get a sense for the detail here within even the M family at AWS. There's potholes or opportunity all through this. What if you change family? Go burstable or memory optimized or to compute optimized. Maybe your workload would be better suited for those instances. How would you ever do this as a human? Because not only are there many, many instance types and attributes and features within, and Azure is no better. In fact, it's even more difficult because their naming convention makes it look like you could live and make a choice based on naming. You cannot do this manually. And it's why in most organizations, instances are chosen because of what people know and what they're comfortable with. And that is not how you optimize. So the detail is really important. The detail as shared within a recommendation is also critical, because if you go with a very general suggestion that someone should move from one instance type to another, they're going to want to know what drove that And so ICO delivers a reminder of, for every recommendation, what was the policy that fired? How do you look within your busiest day in your existing instance type? What would you look like on your busiest day if you took the recommendation? And what is the financial impact of making that change? So for an app owner or an engineer, they can understand and see empirical proof that the recommendation is actually safe. And as a reasonable human, would you please approve this or go and do it and go and make the change? And we do this at scale for every recommendation. If you look at an example of using some of the free tools, not to pick on Azure Advisor, but I will actually, a large finance company that we deal with, their Azure recommendations for a given piece of infrastructure came up with almost 100 recommendations, no consideration for cross-family or cross-generation. They included some suggestions to shut down some stuff that were actually disputed with deeper examination. Densify generated almost 2,500 recommendations, only 10 shutdowns, a lot of things that were suggested personality-wise to fit different families, almost 2,000 suggestions where an engineer picked something that didn't actually fit the personality of the workload. And the net effect of this, I think in the Azure case, the Azure Advisor case, I think it was about 100,000 in savings. I think the Densify case in this instance was about 3 million in savings. Now you might say, well, that's a lot of changes to have to go make. Andy will demo how you can ask Densify to actually tell you the things that are easy to do so that you can go and chase those as the low-hanging fruit. So let's jump over and have a demo. Andy, you all set?
So I'm going to flip straight over. This is not going to be a full-blown demo. I want to get to the meat and potatoes fairly quickly. So we move off the summary screen and move to the data screen, which is a nice way to summarize where the opportunity is. If we're addressing cloud burn here, one of the nice ways to do that is using this data dashboard, which allows us to work with the different tags that we might consume from the public cloud. In this case, we're looking at a combination AWS, Azure, and GCP, and view this by owner. This is what we're looking at right now. A quick way to be able to dig in and say, all right, I want to focus in on where is my largest opportunity. And the fastest way to do that typically is either who is spending the most money or who has the largest savings opportunity based on, looking at those instances, looking at the recommendations and saying you could be operating a lot more efficiently by matching that demand with the correct amount of supply. And oftentimes we'll see, customers using a fraction of the amount of resources that they really should be using. And then there's other ways to view the information here. So the key thing is we give that viewing, that visibility, and this is what a lot of other tools out there will do. So you need to have this, there's no question, to be able to get an idea of where the opportunity lies, who's spending up all your cloud dollars. But now you have to do something about it. To your point earlier, Chuck, it's no good if I give someone a recommendation that's based on, say, 14 days of average utilization, or I give someone a recommendation.
And lots of tools will give you basic recommendations. There's no question. There's no shortage of recommendations, right?
That's it. And some will give you, hey, here's 3 different ones to pick from. And then it's up to you to try to determine what to do. So I want to dig into a couple of the actual recommendations themselves, and let's drill in, say, using something like a business unit or something. And just by viewing differently on the tags and things, now I can view this information with a different logical slicing here. So let's view it by, say, a business unit or application. Now, I'm going to actually take a small subset of recommendations because it's just easier to consume when we're looking at, a fast demonstration of the software here. This is similar to a recommendation that we were looking at earlier. So I'm going to dig through this one just to look at, what exactly is Intel Cloud Optimizer going to show you from an opportunity perspective. So It will drive through everything that you're running is infrastructure as a service, the RDS, your auto scaling groups, and of course containers is a completely separate subject for today, but let's focus on the public cloud. So it'll cover all the three major clouds. The recommendations when we get to them actually look at individual instances. In this case, we're looking at the EC2 or the VMs or the machines. It will tell you exactly what that recommendation is, C4 extra large to an M6i in this case, so one of the newest Intel chipsets. It will look to whether or not you've got coverage for your current RIs and savings plans if you're currently covered, or it doesn't make sense to actually optimize out of that, something like a standard RI, then we'll just leave it there, no recommendation. It will look at how often, or at least how much this thing is running, and make an estimate as to what your potential savings would be on a monthly basis, or in some cases where we're actually recommending more resources for something, what's the impact on spend? Because you might have to spend a little more in order to address a service level. Down here at the bottom, you will see the actual before and after. Chuck alluded to that in one of the slides that shows the impact analysis report that says, when I take that, say, the initial pull will be 60 days worth of data. The software will build a predictive model for every single metric that it captures agentlessly, using in this case something like CloudWatch, or no agents required. And it will build that hourly predictive model to say, what is this thing doing on an hour-by-hour basis based on learning from the past and predicting a 24-hour window in the future. Blue being current and green being what's it going to look like when we actually move to that new instance. It includes a predicted day. It'll include the very busiest day that it saw through that whole period. So this is like your worst case scenario. And any other statistics that it'll pull: disk IO, memory if it's available, network IO bytes, packets, what have you. One of the key things, I won't get through everything here, but let's just look at the effort level, because this is where the low hanging fruit is. So when we look at the effort level detail, so what's it going to take to actually move, in this case, from a C series, so compute optimized to general purpose, the software will automatically detect differences from one instance to the other, and suggest, you might want to go after the ones that are either low or no effort level. By contrast that with something like this moderate one. So there's some differences in this particular recommendation, which is an upsize from an M3 medium to a C5 large. So there's differences in the hypervisor. We want to make sure that we're not optimizing you out of, say, coverage on capabilities for IOPS. So if this is, say, a SQL instance or something, or some sort of a database, that could have some significant impact. So it's calling that out. And this is all configurable. Some customers will say, well, I never want to see this combination, so I want to increase that effort level for certain sort of things that we would encounter. And so really important, and again, every single recommendation is covered by something called this impact analysis report, which is something that we typically would attach to, if there's an approval process to move from one instance to another, then we would do so. This would attach to something like a ServiceNow or a Jira ticket. So every amount of detail that you see within the actual analysis is included in this report, which is typically something that someone would look at an app owner report and say, as a reasonable human, as Chuck likes to say, would I approve this? As opposed to just saying, look, it's going to save you $40 a month, trust us, it'll be fine. All you need to do is make one recommendation that doesn't work, and those app owners are never coming back to the table to take one of your recommendations ever again. So we have customers actually that have done this. They've tested it out, and typically there's a crawl, walk, run. They'll test it out in a small area manually, then they'll apply it to something like a test account of some kind, and then move to production and actually implement this with automation. When customers saying we've done well over 1,000 recommendations in the last quarter, none of them turned over. Every single one of your Densify recommendations are being implemented automatically.
If you'd like to find out if you qualify as an organization for ICO, or you just want to talk to us further, actually, it's a great way to go. But a couple questions. Timeline for Densify to learn from current infrastructure before it can start recommending. It's a great question. Every workload is different. You might have a workload that behaves very differently on a daily basis. You might have something that should be watched for a quarter before a recommendation is made, and that is one of Densify's policy settings. So for a given workload or a given piece of infrastructure, you can say exactly how much history should be observed before actioning. Great product and presentation. We love the compliment. What safety buffer is built into the recommendation calculations? That is also a policy element where you can specify how much white space or conservatism you want to be applied to a particular infrastructure. For instance, for production critical, you might leave much more headroom than, for instance, maybe something that's running a batch overnight that no one's waiting for.
I might just jump in and also suggest, percentiles are also in there as well. So for some workloads, you might say, hey, I want to do 99th or 100 percentile. These are production critical. Whereas a test have environment, maybe I'll just do 95 or 96 percentile and throw out the top 4%. So there are a number of settings inside the policy engine that has any number of safety buffers. Great thing, they're set out of the box. Most customers will change maybe 5% of those settings before they get started. So you don't have to build these things from scratch.
Yeah, that's part of the expertise we bring to the table as part of the process. Will most customers have 12 months of utilization data, or do you have to wait until the data is captured? Most environments will have, I think, 60 or 90 days, Andy, through CloudWatch, for example?
Yeah, we'll pull 60 to start with from the cloud, and then if we need 3 months worth of data, then we'll sit and capture that, unless they have a repository of data that we can actually load of time series data. So that is also an option in some cases. The customer has granular enough data that we can actually leverage.
Can it be used for assessing on-prem workloads and recommend cloud instance for migration? Densify has a rich history actually in on-prem environments. All of our focus though today is on cloud and containers on-prem or off. We prescribe actually that you over-provision intentionally when you move workloads. The beauty of the cloud is the flexibility. We recommend something we call a soaking pool method, where you over-provision or provision like for like, and then have Densify watch those workloads on the cloud side and recommend, after enough time has elapsed, a right sizing or correcting to bring that back in line. Used to be back in the day, you would spend a whole bunch of time analyzing existing and on-prem workloads. We say do it after. Move fast, do it after. If you're going to cloud, go fast, knowing that you can correct as you go. If a JIRA ticket is created with a recommendation, what safety mechanisms are there to make sure the recommendations are not stale by the time the recommendation, the ticket is approved / actioned? Andy, that sounds
like a question for me. Yes. So it would be part of the integration actually. So if something sat there in someone's queue for say 72 hours or whatever, part of the implementation that we would do would be, how much time elapses before someone hits approve. It's like, okay, that thing's already stale. It has to be done within 24 hours. So it's basically part of the standard integration where that question gets answered. And maybe it's a different answer for certain types of recommendations as well.
Great questions. Thank you all for them. And also welcome you to follow us, interact with us through these various channels, conveniently with QR codes there to take you directly to them. Thank you all. Have a great day. And thanks, Andy, for your content.
Thanks, everyone. Take care. Have a great day.